So to set the framework, I had that little path to enlightenment comes from the Maltwood Museum, but it sort of sets the cultural background behind what I'm hoping to talk about. I want to suggest a very general sort of context, just to help in clarifying concepts, illustrating the way I'll be using the language a bit. I've labeled this conceptual framework the staircase to sustainability, but you could think of it as the path to enlightenment. But in order to get serious, I'll move on to ask, what is digital fissures, which requires me to talk a bit about what's Ocean Networks Canada. And then I'll try to suggest ways that, in the context of the staircase I'll introduce, how digital fissures works towards more participatory sort of activity. And that really means moving into what some people call civic science. And the question then is, how could you move the crowdsourcing activity, the engagement of people in the crowdsourcing activity towards civic science? And then, if there's time, we could reflect on some other things. I realize I'm sort of preaching to the choir here, and the real challenge is to know how we take this message out, not just into the congregation, but out into the larger community. So there are a lot of web-based capacities around that I'm not going to talk about. You're more familiar with most of them than I am. I do want to talk about citizen engagement in a fairly focused way. But I want really to emphasize the need, so far as my discussion is concerned at least, to distinguish two different aspects of that engagement. One is the engagement of crowds of non-specialists in activities that are leading to improved science and understanding, knowledge building. And the second, the engagement of crowds that will carry a lot of diverse perspectives, a lot of conflicting impressions into discussion of improved policy that rests on that database, rests on better reconciliation of the contending interpretations of that evidence and the associated risks and the balancing of the consequences of alternative responses to the data. Processes that span both have been talked about here, and there are many more that we could pursue if time permitted, but let me go on. I'm really starting from a background in some questions that have been around for quite a long time. A lot of considerations are tucked into this staircase discussion. Some people would see the left-hand side of the graph as corresponding to some of the right brain activity that Ian McGilchrist and others have talked about, or system 2, I guess, that Danny Kahneman talks about, whereas the right side is really reflecting this very much more analytical, post-enlightenment left brain. But what I want to do really is just use this kind of framework. In a way, some people could see that staircase as the first half of what would be taught as a policy cycle. If you came back down around the back, you'd be looking at the implementation phase, but this is the policy formation phase of the story. Oops, I want to talk about Ocean Networks Canada. Some of you will know about it, I expect. It is another nonprofit corporation inside a university, which is, I think, an interesting parallel. It operates cabled ocean observatories. These observatories consist of instrument clusters that are placed on the seafloor. They're connected by fiber optic cable. They collect data on physical, chemical, biological, and geological aspects of the ocean floor over very long time periods. They broadcast out of these instrument nodes continuously, 24 hours a day, 365 days a year. The Neptune Observatory off the west coast of Vancouver Island has about 800 kilometers of fiber optic cable and 5 nodes, instrument clusters. The earlier one, Venus, Lorena Tunnicliffe's initiative in the Strait of Georgia, has about 50 kilometers in the Salish Sea. Together, these make up the Ocean Networks Canada Observatory. It streams live data from instruments at key sites on the ocean floor, streams via the internet to scientists, policymakers, educators, public around the world. It's open source, it's readily available. And one of the interesting thing for me was that in addition to the instruments that capture numerical observations, there are hydrophones and there are video cameras on these instrument clusters. Now, even though these video cameras are operated only 5 minutes every hour, because these are on the seafloor, the hope is to avoid perturbing the environment by turning on the lights for long times. So they operate 5 minutes every hour, but they operate every day. So they generate a fire hose of data images. Rough estimate is that 5 minutes every hour accumulates to over 700 hours of video footage per camera per year. 5 cameras generate 3,500 hours, just 100 working weeks, which is 2 full years of work just to view them, not to do anything with them, just to view them. Interesting point, this is all open access to all these data, except for one thing. Intriguing little negotiation went on because the hydrophones, of course, pick up signals from marine traffic. Signals from marine traffic is a matter of some sensitivity so far as the US Navy is concerned. And so the data from that instrument are filtered through a US Navy site and periodically cleaned up before that gets out. Everything else is open access to all the research community anywhere in the world, but this one instrument is cleaned up. And interestingly enough, of course, it's not cleaned up only when there are signals of interest. It's cleaned up sometimes when there are no signals of interest, because obviously you don't want the absence of evidence to be conclusive evidence of absence. So anyway, all this massive body of video data is out there. It is video. It's not currently amenable to machine processing. And that was what gave rise to this project. In the absence of the alternative of processing with software agents, this volume of data will overwhelm the capacities of the global scientific community. So it's exactly the same motivation as gave rise to Galaxy Zoo. There are not enough scientists, or particularly there are not enough graduate students in the world to examine all these images. And in particular, these images are video images. They're not just static. They're orders of magnitude more challenging for the purposes of pattern recognition. So the goal of Digital Fishers is to explore this crowdsourcing option, harness the internet-based volunteer efforts of this large number of non-expert participants as a first-pass alternative to machine processing when we can get there. It's an interesting question, mentioned several times this morning. These contributors that we're attempting to attract may be motivated by nothing more than, in a sense, the curiosity, the entertainment value of the activity. But obviously what we hope is that they'll get seriously drawn into the enterprise of improving the science itself, just as is happening with Zooniverse and Galaxy Zoo and the other projects under the Citizen Science Alliance. There is this very interesting question, which was talked about several times this morning, that in addition to providing this basic functionality for easily viewing and annotating the Neptune Canada video data, this dataface interface faces the challenge of persuading volunteer participants to engage with the Digital Fishers process across multiple iterations and ideally for long time periods. There is, of course, the argument about the long tail, that if you can get large numbers of people to contribute only a few times, you ultimately will accumulate a substantial number of observations. But in fact, we're really hoping to engage enough people. Maybe it's through some kind of gamification, engage enough people to the site to assure some statistically reliable annotations and enhancement of the database. There are several research projects along that line in train, but we had some conversation at the table I was sitting at about these questions of motivation, whether people who are involved only because of the game aspects of the interface can really be taken seriously by the scientists that they're supposed to be serving. I won't go into the statistics. This is only to illustrate the back end of this digital fishers interface. The data are accumulating. We're lucky they accumulate in massive databases operated by Oceans Networks Canada in Port Alberni with backup in Saskatchewan. And as I say, they are available to anybody at any time who wants to log in and observe or download any of this massive data. And notice in the middle there, just to note the kind of annotations we're seeking from the participants, talk about the sea critters, in this case hagfish. Hagfish are present. There's a wonderful little incident if you look at YouTube in which a 14-year-old kid in Latvia, I think it is, or Estonia, happened to be looking at the video clips, and he saw this extraordinary event with something or other appearing out of the top of the screen to scoop up a hagfish. And nobody knew quite what was happening. He referred the event to the scientists. Ultimately, they concluded that this was an elephant seal which had come down from the surface to pick up this fish at 950 meters deep. Nobody knew that elephant seals could get down that far. That's a long trip, and a long time you hold your breath. But anyway, this is one little clip that was of interest, drew a little bit of interest on YouTube. But there's also observations about the water condition, turbidity, and so on, seafloor conditions, and the presence of man-made objects, which could, in fact, at one point it was the subject of a search, a campaign to look at debris on the ocean floor as one specific question that we put out to the participants. So the first part of this staircase, just to come back, these steps, measuring to create observations, storing the observations to create records, organizing to create data. In professional science, which is a label carefully chosen not to be either fundamental science or basic science, but in professional science, there are very well-established protocols for how this is done. We are now wanting to work from the other side with the community from the outside, and the science-oriented crowdsourcing is basically the first stage with which Digital Fishers attempts to introduce. But in a way, you should be able to see Digital Fishers more generally as something like a boundary object that supports the interaction of scientists and outsiders, but ideally supports it in a way which does create the interaction rather than simply the one-way flow. So there's the general annotation exercise to create the kind of big database that I mentioned. Oh boy. But there's a more specific kind of exercise to use this not as a general broadcasting of images for annotation, but as an instrument for particular scientific exercises. So drawing on the crowd for particular purposes. This sablefish campaign is one in which we're trying to deal with the question of quality. The exercise is structured so that we're gathering information from digital fishers players, from university marine biology classes, individual subject matter science experts, and an algorithm currently under construction with an undergrad student at UVic. If you go to YouTube and look for digital fishers, you'll see a very interesting exercise in pattern recognition where the algorithm is starting to pick out the moving fish in a 1-minute clip. Okay, well, there's a lot of education questions that can be picked up. There is a tutorial capacity built into the activity, which gives people the opportunity to pursue their sort of education in marine biology. There are some tremendously interesting research questions around how you can do that effectively, working people through the levels of capacity and experience in digital fishers, and looking at the questions of qualification built by working through various steps. But there's also the exercise to become more broadly engaged. This is Mr. Harper's visit to Cambridge Bay, where there's now another instrument cluster on the seafloor, autonomous, but it's at the service of the local high school, the local college, and the local community. It has things like ice thickness sensing capacity, so the community can really become engaged in monitoring seafloor conditions in a very substantial way. There's also a similar thing at Brentwood College now, and what it introduces is the possibility of networks of colleges. And one of the things that sort of there is pie in the sky is a circumpolar network in which you've got all of the circumpolar nations and indigenous communities engaged in the exercise, working from their own autonomous instruments, but engaged perhaps in some friendly competition around the whole knowledge building process. Okay, so I don't have time to go into this, but basically the next stage to get up a little bit further into what was referred to this morning in Mode 2 science, the need for robust peer review, the need to look at a different way of legitimating professional science, and this question of civic science that builds the capacity for really substantial engagement around the interpretation of the evidence, the building of the perspectives on what the evidence tells you. It's still, of course, a question to know what are the possible policy responses and how you would weigh the particular options there. There was some mention this morning of problems of the war on science that we seem to be engaged in at the moment, and the suggestion that maybe the capacity that we've all been talking about here puts into the hands of citizens the capacity to do a lot of the monitoring, which earlier we had thought to be a responsibility of our governments. So this particular one is looking at Coastbuster, looking at the identification of debris from the tsunami across the Pacific. This is an interesting one, trying to build a network of observers who will be looking at radiation issues rising out of the radioactivity from the Fukushima event. The interesting thing there is that it is important to emphasize, as Muki Hakle, I think, did in the last meeting, how much now of the science technology, what used to be embodied in the scientist, is now embodied in the instruments that anybody can hold in his or her hand. And so the capacity for the amateur scientist to be doing the work of the professional scientist is in part made possible by this embedding of the technological knowledge that's built up in the science community into the instruments that can be distributed. So here's an opportunity if you want. You've got till the end of the month. Propose what should be the next great citizen science project. If your project's selected, Arizona State University Center for Policy Informatics will put up $10K to finance it. So you could take advantage of that possibility. I guess I don't have time to go into the reflections on a changing world. I'll leave that with you and observe that in the end, we're coming up to the question of democracy that was raised in a couple of conversations this morning. And I guess I'll have to leave it there. We can pursue the question of which kind of democracy, maybe over the posters. I'll leave them. This need to develop trust and coherence in safe places is really important. But the other thing is, you have to remember that we really can't think outside the box of the representative democracy that situates this ultimate decision-making authority in elected representatives that act on the basis of their interpretations and their contextualization of the relevant evidence. So we're looking at how much influence the community might have, how much influence getting consensus within the community might have on the thinking of decision makers. But most of the discussion is carried on within the confines of that box. Some people argue that ultimately we need to consider not just civic science informing elite decision, but maybe what Jim Tully calls civic society, and that includes possibilities for civil disobedience, continued contestation, agonistic dialogic democracy, and that's obviously a topic that's worth pursuing, but it's obviously for a different time. So thank you very much.
Thank you.